Good day, folks. Welcome to Bridesman Academy, where we bring brilliance to every lesson. Now, let's look at Euclidean geometry, okay? Now, it says to us in the diagram, O is the center of the circle, okay? Now, I like to do this when I'm dealing with geometry, okay? I like to collect my data like this. Like the first one, O is the center, okay? The second one that is important, K, T, and L are points on the circumference on the circle. K, T, T, L, K, K, L, O, K, and O, T are drawn. Okay, O, T intersects. There is a difference between intersect and bisect. Intersect means if I'm having something like this, they just intersect. Okay, but bisect means now this one cuts exactly in half. Okay, that is bisect. ST is a tangent. Okay, tangent, I have a tangent, I don't care which one is a tangent, then yeah, I'm having those, then these angles are there. Okay, there is no way I'm gonna answer my question, sorry, there is no way I'm gonna answer all my questions without having reasons like this one. Before looking at the question, let's now try to find answers for ourselves. Okay, now I'll start here, center. Okay, let me see. At center, angle at center is twice angle at the circumference, right? So I know angle L, actually angle KOT, it is twice angle L. I know the reason. Okay. Now I can see line from the center perpendicular to the chord. You still remember that one? Line from the center, it is perpendicular to the chord. Okay, line from the center like that. So it means now if I can, okay, I'm not so sure here, but yeah, okay, this one let me not write it, I'm not so sure, but yes, we might be asked to prove that this is 90 or these two are equal. Okay, we don't know. Then I move on to a tangent. What about a tangent? Tan chord theorem. Okay, let me do this. A tangent, an angle between a tangent and a chord, which is 36, it is equal to the angle subtended by that chord, which is angle L. Now angle L, it is equal to 36 degrees Y tan chord. Okay, I move on, and another theorem says if I'm having a tangent and it is a tangent perpendicular to the radius. So if I'm having a tangent passing through point T and a radius touching the tangent at point T, that angle they make it is 90. So now it means now if I know that, it means I know that angle T2, it is equal to 90 minus 36 degrees, which it is equal to in this case 40, 40, 44 degrees, no, 54. Okay, let me see. 90 minus 30, it is 60, yes, 54. 54 degrees. Y tan perpendicular to radius. Okay. Uh, Another thing that I can see, okay, this one they didn't mention it, but can you see that if this is a radius here and this is a radius here, the angles this one and this one will be equal. Okay. Yes. Okay. Yeah, I think that's one. I think that's all I can get. Now determine angle T2, giving reasons angle T2. Can you see the importance of analyzing my sketch before moving on? Now I've already found T2 as to be how much? As to be 54 degrees Y, tangent perpendicular to radius. Now angle L, did I find angle L? Angle L, it is equal to 36 degrees. Y already gave a reason tan chord theorem. You see, this is the importance of analyzing my data thereof. Now, K angle OT, any information about it? K angle OT, it is equal to twice 2L. So it means I'm going to say now K angle OT, it is equal to what is twice? Okay, what is angle L? It is 36 degrees, which is equal to 72 degrees. Now, remember you want a reason. Remember reason is angle at center. It is equal to twice angle at circumference. You are done. This is your reasoning and all. Can you see? Can you see now? Prove that Km it is equal to ML. Let's see that. Km it is equal to ML. Okay, we are required to prove that these two are equal. How can I do that? If okay, if I can prove that this angle here it is 90. Remember this theorem here that says line from the center is perpendicular to the this one. Therefore, it bisect this one twice, right? Do you see that? Do you see that one? Yes. So now let's just prove that TMK, or rather this angle here. Yeah, let's prove that. Okay, okay. Can you see that I already have this angle, right? As how much? As I removed it, but it is 72 degrees. Okay, I can find this angle here, which is KMO. Okay, let me find KMO. KMO, it is equal to 180 minus 72 degrees minus 18 degrees. Why am I saying that? Sum of angles in a triangle. Now, when I do mathematics, I get that one KMO it is equal to 90. So if this it is equal to 90 here, so this it is also equal to 90 using angles in a straight line. Okay, but even though I only find this one as 90, it's fine. Can you see that line from the center? It is perpendicular to the chord. Yes. Now I can conclude and say now uh, Km it is equal to ML. Why am I saying that? I can see now the reason is a line from the center perpendicular to the chord. Now I had to confirm that this is 90 degrees first because the examiner did not give me. Okay, yes. So that is it. Then 8.2 now. In the diagram, that one is drawn ABC such that yes, AB is parallel to DC. We are given that. The important one is here. RB to BS. RB to BS. It is in a ratio of 5 is to 3. What I want you to do is say 5A, 3A. It is not the length, it is the ratio. So it can be 15 and 9. So when I divide by how much? By 3 here and by 3 here, it gives me 5 equal to 3. So it is just the ratio, okay? So hence I'm saying 5A. We do not know the exact, okay? And we are given, okay, the other information we are given here. All right. Now prove that giving reasons, okay? Sorry. Prove giving reasons that BC it is parallel to AD. Where is that BC? BC it is parallel to AD. AD is here. But I can also extend that line to like something like CO, okay? Yes, I can extend that line. Remember, if I'm having a straight line here, then let's say it is A, B, they are not necessarily equal. C, the gradient of AB, it is equal to the gradient of MB, which is equal to the gradient of AC. So the gradient from here to here it is equal to the gradient from B to there, also equal to the gradient from there to there. Okay. Remember collinear. Yes. So this is the same as now trying to prove that that one is that one. Okay. How can I do that? Okay. Now, can you see that I'm gonna have a closed triangle like that? Okay. something like these. So remember, I'm trying to prove that these two are parallel there. So if if this side, the ratio of these two, actually let me say the ratio of this to this, if it gives us something like 5b and 3b, now can you see now it is equal to the ratio of this to that? So it means now the lines are parallel. Okay, now let's see what DC divided by CS give us. DC divided by CS give us. Okay, now we're gonna say now to us DC divided by CS, it is equal to what? What is DC? DC, it is 20 divided by what is CS? It is 12, and this simplifies nicely to 5 divided by 3. Now can you see now that if this is 5 divided by 3 like this, and also this one it is 5 divided by 3, these lines are parallel because now proportionality theorem applies. Now they're off. Okay, we're gonna now say they're off. Therefore DC divided by CS, it is equal to what? To RB divided by BS. This one, it is equal remember RB divided by BS, it is the same as 5 divided by 3. If I convert this into this part, okay? So they are equal, they're equal. Therefore, if that's the case, therefore now it means BC, it is parallel to AD, but we need a proper reasoning thereof. Okay. Okay. Firstly, we can say it is parallel to DR. We can say it is parallel to DR. Okay. Why are we saying that? Converse. Remember, when you try to prove something, you use converse. Converse what? Line parallel to one side of a triangle. Of a triangle. Okay. Or you can say sides are in same proportion. Okay, but now we are required to prove that BC, it is parallel to AD. Remember, I said the gradient for DR and AD is the same. Okay, you can also come here and do but what's important here is the reasoning either way. Okay, now that we know these two lines are parallel, we might just need to add that. To our sketch. Allow me to use two arrows. It is the same as this one again. So yes, now it is further given that RD, it is equal to 48 degrees. RD, it is 48. This one, it is the exact unit. Okay, so hence here I like to say 5A 3A, so that you can see that we are not talking about the dimension, rather the ratio. Okay, 48 units. If I do not have anything here, it means now it is the exact unit, right? Now calculate the given reasons, the value of the ratio between AD and AB. AD and AB. Now AB, if I look at this one, this is just a parallelogram, okay? And a parallelogram has nice properties thereof. That says to us opposite angles are equal. Similarly, opposite sides are equal. So this is gonna be 20. This will be, yeah, that is 20. Okay, we now know AB is equal to 20. Okay, we have to add that AB is equal to 20. Okay, let me remove this. Because we have to know, the examiner has to know where we get it. Okay, we'll just say AB, it is equal to 20 units. Okay, while opposite sides of a palm, which is a parallelogram. Okay, now can we find a AD, because we need AD. Yes, I can find AD if I use these parallel lines here. Okay, can you see that if I use these parallel lines here, This will give me something like a proportionality theorem again. Again, yes. So now, if these two lines are parallel, now I can say this to that, it is equal to that, okay? But now, depending on what I want. So what I want it is AD. AD. This is what I'm looking for, okay? So I'm going to set up an equation that says AD divided by the given. I want to use everything that I have. RD, I have RD, okay, I have the exact value of RD. It is equal to, what is it equal to? Now, can you see instead of equaling RB, it will be equal to RS. It will equal to RS because RD it is the longest side. So RS it is equal to the sum of these two, which is 8A. Okay, divide by BS. We can say RS divided by BS, okay? RS divided by BS. Oh, okay, I started with AD here. So check, if I start with AD, the small one, it means also on the other side I should start with the small one, which is BS. Okay, then I followed with the longer one, which is uh, RB in this case. Uh-uh. The longer one is what? RS or RS. Okay. Now let me repeat that statement. Let me try to remove this. I'm saying I was given RD, right? I know the exact value of RD, and the examiner now wants what? AD. Okay. Now I'm gonna use proportionality theorem and say I'm gonna use now in this side RS and what and BS because they're in proportion, right? Yes. So I'm gonna use this, but remember this was 5 and this was 3. But I like to use this. So this is 8A, okay? And this is 3A. So we do not need that one. So we can use that and say now AD is what I'm looking for. Divide by what is RD? Okay. What is RD? Now RD I was given as 48 units. Okay. It will equal to what? BS. BS BS it is 3. You can just say 3. Okay? 3. Even if you say 3A, I'll show you something. Let's say 3A divided by what is RS? RS, can you see now? RS it is 8A. Can you see that these A and A will cancel off? Okay? Now I can just cross multiply the off and play with mathematics. Now I can say now therefore AD it is equal to 3 divided by 8. Then I multiply this to the other side. Multiply by 48 thereof. Therefore AD will be equal to something like 8 times 48 divided by 8, it is something like 6. 6 times 3, it is 18 units. Okay, now I know AD, it is that one. I know AB. Now I want the ratio of AD to AB. What is AD? AD it is 18. What is AB? It is 20. So when I simplify this, it's gonna simplify to 9 divided by 10. 9 is to 10. Final answer thereof. All right. Yes, that was all for question 8. Let's meet on question 9 thereof. Thank you.